The date was May 1940. In the skies over Dunkirk, the Royal Air Force was engaged in a desperate battle for survival. The Spitfire, the elegant elliptical-winged savior of Britain, was performing miraculously. But on the ground, the Ministry of Aircraft Production was staring at a spreadsheet that spelled doom. A Spitfire required roughly 5 tons of bauxite ore to produce the aluminum needed for its airframe. And Britain was an island under siege. The supply lines were being strangled by U-boats. The strategic reality was stark. You could have the best pilots in the world and the best engine in the Rolls-Royce Merlin, but if you did not have the light silver metal to skin the wings, the war was lost. Aluminum was not just a material, it was the single most critical strategic resource of the air war. It was the only metal that combined the strength to withstand a 9G pullout with the lightness to allow a fighter to climb to 20,000 feet in 7 minutes. In 1940, the Axis powers held a terrifying advantage. Germany, through massive state subsidies and a focused industrial policy, had become the world's largest producer of aluminum. The Luftwaffe was flying on an ocean of light metal. The Allies, meanwhile, were facing a bottleneck that threatened to ground their air forces before they could even join the fight. This is the story of how a critical shortage turned into an obsession, how a monopoly was broken, and how the kitchens of America were emptied to build the armadas of the sky.
To understand the desperation of 1941, one must understand the metallurgy of the metal itself. Aluminum is the most abundant metal in the Earth's crust, but unlike gold or copper, it never appears in its pure state. It is locked inside a red, clay-like ore called bauxite. Unlocking it is a nightmare of chemistry and physics. First, the bauxite must be boiled in caustic soda to create a white powder called alumina. Then, in a process known as Hall-Héroult, that powder is dissolved in a bath of molten cryolite and blasted with massive amounts of direct current electricity. It is so energy-intensive that engineers often refer to aluminum not as a metal, but as congealed electricity. To produce 1 single pound of flight-grade aluminum requires 10 to 12 kilowatt-hours of electricity, enough to power a modern home for a day. In 1940, the United States produced 206,000 tons of aluminum. Germany produced 240,000. But the terrifying statistic was capacity. As Hitler conquered Europe, he seized the smelters of Norway and France and the bauxite mines of Hungary. By mid-1941, the Axis controlled 54% of the world's aluminum capacity. When President Roosevelt issued his famous call for 50,000 airplanes a year, the math simply didn't work. The U.S. aircraft industry required an estimated 1.6 billion pounds of aluminum to meet that goal. The total national output was barely half that. There was another problem. In the United States, aluminum was a monopoly. One company, Alcoa, the Aluminum Company of America, controlled 100% of the virgin aluminum production. They owned the mines, the refineries, and the smelters. While they were efficient, they were cautious. They had resisted expanding production during the Great Depression to keep prices stable. Now the government was demanding they triple their output overnight. The bottleneck was immediate. In early 1941, aircraft factories began to report shortages. At the North American Aviation Plant in California, P-51 Mustang prototypes sat unfinished, gliders waiting for their metal skins. The Secretary of the Interior, Harold Ickes, famously declared, "When a bird can fly without wings, we can build airplanes without aluminum." The crisis gave birth to one of the most famous and psychologically potent campaigns of the war, the aluminum drive. In June 1941, the Office of Civilian Defense launched a nationwide appeal. The slogan was simple: pots and pans for planes. The government asked every American household to scour their basements, attics, and kitchens for anything made of the precious silver metal. Old coffee percolators, worn-out skillets, cigarette foil, ice cube trays, and cocktail shakers. The response was hysterical and patriotic. In July 1941, town squares across America were transformed into metallic mountains. In New York City, Mayor Fiorello LaGuardia ceremoniously tossed the first pot onto a pile at City Hall. Movie theaters offered free admission in exchange for an aluminum pan. Boy Scout troops mobilized like paramilitary units, pulling red wagons door to door, demanding scrap. The narrative sold to the public was direct: give us your skillet today, and it will be a Spitfire tomorrow. In reality, the metallurgy was more complicated. The aluminum used in cookware is relatively soft and pure. The aluminum used in a B-17 Flying Fortress is a complex alloy, specifically 24ST alclad, which contains precise amounts of copper, manganese, and magnesium for strength. Mixing millions of random pots and pans created a dirty alloy that was difficult to refine back into flight-grade material. Metallurgists at the time knew that a melted-down coffee pot would likely never become the wing spar of a fighter plane. That part required virgin metal. But the scrap was still vital. It could be used for non-critical parts, engine blocks, and training aircraft, freeing up the pure virgin aluminum for the frontline fighters. The drive collected 70,000 tons of scrap metal. While this was a fraction of what was needed, its true value was psychological. It made the war real. It connected the housewife in Iowa to the pilot in the Pacific. It created a sense of shared sacrifice that prepared the nation for the rationing to come.
But while the public was piling up pots, the real war for aluminum was being fought in the boardrooms and the river valleys of America. The government knew that recycling wouldn't win the war. They needed massive industrial-scale smelting. They needed to break the monopoly and find enough electricity to turn the lights out on the rest of the country if necessary. This brought two giants into the ring. On one side was Arthur V. Davis of Alcoa, the aluminum king. On the other was the government, represented by the aggressive head of the Reconstruction Finance Corporation, Jesse Jones. Jones made a decision that would alter the American industrial landscape forever. He decided to finance a competitor. He threw government money at the Reynolds Metals Company, a maker of cigarette foil, and told them to become an aerospace giant. R.S. Reynolds, a man who saw the war coming before most, mortgaged his factories to secure the loans. He began building smelters in Alabama and Washington State at a breakneck pace. But a smelter is useless without power, and this is where the geography of the war shifted. To build the Air Force, America had to harness its rivers. The Tennessee Valley Authority, TVA, and the Bonneville Power Administration in the Pacific Northwest were ordered to prioritize aluminum above all else. The Grand Coulee Dam, a concrete monster on the Columbia River, became the beating heart of the aircraft industry. Massive high-voltage transmission lines were run directly from the dams to the new smelters springing up in the wilderness. In Spokane, Washington, and Muscle Shoals, Alabama, the pot lines ran 24 hours a day, glowing with the heat of 960 degrees Celsius. The process was relentless. Ships risked the U-boat-infested Caribbean to bring bauxite from Suriname to New Orleans. There, it was refined into alumina powder. The powder was put on trains and shipped across the continent to the Pacific Northwest, where the cheap hydroelectric power turned it into metal ingots. Those ingots were shipped to rolling mills in the Midwest to be flattened into sheets, and finally, those sheets arrived at the aircraft factories in California and Detroit.
It was a logistical circle of 20,000 miles, involving ships, trains, and trucks, all to produce a sheet of metal 1/16 of an inch thick. By 1942, the shortage began to ease. By 1943, it turned into a flood. The output was staggering. In 1939, the U.S. produced 327 million pounds of aluminum. By 1943, that number had skyrocketed to 1.8 billion pounds. The shortage that had terrified the War Department vanished. In fact, production became so efficient that the government eventually had to ask people to stop saving foil balls because the processing centers were overflowing. This avalanche of silver metal allowed for the creation of aircraft that were previously deemed too expensive or material heavy to mass produce. Consider the P-38 Lightning. This was a twin-engine, twin-boom monster. It was complex, heavy, and required acres of aluminum skin. In 1940, it was a luxury. By 1944, Lockheed was rolling them out of Burbank at a rate of 13 per day. Or the B-29 Superfortress. This was the most expensive weapon project of the war, exceeding the cost of the Manhattan Project. It was essentially an aluminum tube pressurized for high-altitude flight. A single B-29 consumed 50,000 pounds of aluminum. A fleet of them required the output of an entire dam. Yet by 1945, Boeing had built nearly 4,000 of them. The ultimate expression of this aluminum abundance was the P-51 Mustang. Early in the war, fighter planes were painted olive drab to camouflage them on the ground, but by 1944, the Allies had achieved such total air superiority and aluminum production was so high that the Army Air Forces stopped painting their planes. They realized that paint added weight, about 15 to 20 pounds per fighter, and weight created drag. By leaving the planes in their natural, polished aluminum finish, the P-51 gained a few miles per hour of top speed. The gleaming silver Mustangs that escorted bombers over Berlin were not just a tactical choice, they were a flex. They were a signal to the Luftwaffe that the material shortage was over. The Allies had so much high-grade aluminum that they didn't even need to cover it up. They wanted the sun to glint off it. The war ended in 1945, but the aluminum legacy remained. The United States had built an industrial capacity so vast that it couldn't just be turned off. In the span of 4 years, the U.S. alone had produced 300,000 military aircraft. This fleet consumed more aluminum than the entire world had produced in the entirety of human history prior to 1939. After VJ Day, thousands of these aircraft, the product of scrap drives and hydroelectric dams, were flown to desert boneyards in Arizona. They were parked in endless rows, wingtip to wingtip. The great aluminum fleet. And then the cycle completed itself. The smelters didn't close, they pivoted. The companies that had learned to make wing spars for bombers began making window frames for suburban houses. The rolling mills that made fuselage skins began making siding for homes and cans for soda. The scrap drives of 1941 were a desperate plea from a nation caught unprepared, but they sparked an industrial reaction that changed the periodic table of the American economy. The critics had doubted the feasibility. They said there wasn't enough electricity in the rivers or enough ore in the ground to build an air force of that size. But they hadn't accounted for the sheer will of a mobilized populace. From the grandmother sacrificing her tea kettle to the engineer damming the Columbia River, the result was the same. Every piece of metal played its part. The shortage that threatened to lose the war became the surplus that built the peace. If you enjoyed this story of industrial might, please hit that like button. In the comments, tell us, does the mass-produced B-24 get enough credit compared to the B-17? Subscribe so you don't miss our next deep dive into the truckers who saved the Allied advance, the Red Ball Express. This is the World War II Archives.